A warm welcome to all the students. In the last lecture, we saw an introduction to multithreading in Java, and towards the end of the lecture, we saw different phases in the lifetime of a thread. Okay, different states. So we said that a thread starts with a newborn state. Then from newborn state, after executing the start method would invoke the run method, and from a newborn state the thread goes to runnable state, wherein it is added to the queue that is waiting to get hold of the processor. Then once it gets the processor from runnable state, it goes to running state. Now while in the running state, there are different things that can happen. Okay, the very first thing is, while it is in the running state, it can be abruptly made to stop. So there is a method called as stop. So what will happen is, the thread will stop, although its processing is yet left, it will be stopped abruptly, and the control will pass to whoever is the next candidate who can take hold of the processor. There is another method called as yield method. Okay, now let's say the thread is running and suddenly this yield method is encountered. We have seen that the control is relinquished. So this particular thread is going to relinquish its control of CPU or processor, and it will give the control, pass on the control to the next particular thread, right? And also there are methods, for example sleep method. So whenever a thread is under execution and suppose sleep method is encountered, what will happen is that that particular thread will be put to sleep. That means it will be removed out of the queue, the waiting queue for the processor. It will be removed from that particular queue, so that for a particular period of time, and once that particular period of time is elapsed, it will be again active, right? So in general, thread methods that we are going to see in a program today are: one is yield method, wherein the current thread, okay, it relinquishes the control of CPU, so it no longer uses the CPU. Second is stop method, that abruptly it kills the current thread. And the sleep method, that makes the thread to sleep for a particular time period t, right? So when a thread is running, yield method is going to relinquish the control of CPU. So from running state it will go to runnable state, and whoever is the next runnable eligible candidate thread, that will be running next. Whereas when we are going for a sleep, okay, from running state it goes to a suspended state, and only after a lapse of a particular time it will be again runnable, and once it gets control of CPU, then it will be running, right? So we are going to see the same thing with respect to a program. So in this particular program, I have created a thread class A that extends thread. Now in the run method of the program, I have got a for loop like how I was doing it for the previous program in the last lecture. So for I equal to 1 to 100, okay, it is going to execute this for loop. Now if I happens to be 1, okay, when I turns out to be 1, it is going to call the yield. That means the control of the CPU will be given to some other thread. It will lose the control of CPU. The thread will not execute once the yield method is encountered, right? Then there is another class. There is another class that I have written, that is class B, that also extends thread. So this is another thread. In the run method here again there is a for loop from I equal to 1, j equal to 1 to 50. Now it is going to print from thread B j equal to, so for every iteration it is going to print from thread B and the value of j. Once j is in the third iteration, okay, once j is equal to 3, stop method will be called, and this method called this particular thread called as B, although more iterations are left, but after iteration number 3, once stop is encountered, the thread will be abruptly stopped, okay. So it will just stop here. It will not even be able to print the last statement, that is exit from thread B. It is going to just abruptly stop. It is going to be thrown out, okay. And there is a third class called as C that I have written, okay. Now this is also a thread class, extends thread. In the run method, for I equal to 1 to 200, okay, quite a lot of task is to be done by this thread C. What we are going to do is we are going to print the message from thread C, and we are going to print the value of k, okay, for every iteration. But if k is equal to 1, when k is equal to 1, okay, this particular thread of C, thread C, we are going to put it for sleep for these many milliseconds, okay, and then that is exit from C will be printed, and then your main. Now notice that for sleep method I am using a exception handling mechanism. Shortly we shall see why we are using this exceptions handling mechanism. So I am executing this statement, that is sleep method, under try block, and if there is an exception that is raised, catch block will catch the exception, it will print the exception. Okay, so why we are using try and catch, why exception handling, we shall see shortly. Okay, now in the void main, what we'll do is we'll create thread A of class A, object thread B of class B, object thread C of class C. So in general we are creating 3 threads which are in the newborn state. Then start thread A will be printed on the computer screen, and thread A, it will be made runnable. Okay, then again start thread B will be printed on the computer screen, and after that thread B will be runnable, and then thread C will be runnable. So we are going to just make all the 3 threads runnable. And last statement here is, once this closing bracket is encountered of public static void main, okay, your main thread, which is not declared but it is there, the main thread will be exited. So it will print exit from the main thread. Now in this particular scenario, let us see what will be the output. So this is my program, okay, which has the class A. Okay, now for class A, in the run method I have used iterations for I equal to 1 to 200. Okay, I have already said that I am using yield function. When I becomes equal to 1, it is going to call yield function, and the control of CPU will be lost by this particular thread. Then class B, the iteration is from j equal to 1 to 50. Okay, when j becomes equal to 3, it is going to stop abruptly. The thread will be killed, so you will not be able to see this message. And the third class C, thread class C, that I have created in the run method, again iteration is from 1 to 200, but when k is equal to 1, first time only it will be made to sleep for 1000 milliseconds. Again, why I am using this try and catch, I will tell you shortly. Okay, so now without wasting time, let us run this code. Let us see the output. Okay, now you can notice here, okay, again see the threads, which thread takes the control, which thread is executed, it is purely based on the CPU at every time. So it is not so much in our hand, but only in that particular scenario it will see to it that those particular functions are called, and accordingly it will do the changes. Okay, now you see here thread A, B, C are already started, and then thread main thread is exited. Okay, so at this point we have 3 independent threads which are runnable. Okay, now what happens is, in this particular run, it says from thread A I equal to 1, so it prints I equal to 1, right? Because of the yield method, it will exit from thread A, right? Now thread B, it will take control after thread A is exited. Thread B will take control and it will print first iteration j equal to 1, then j equal to 2, and j equal to 3. Remember that when j takes the value of 3, okay, we have called a stop method in class B. So what will happen is, after printing this line here, okay, the thread B, it will abruptly be killed, and then the control passes to thread C. Right, now you see for iteration 1 till 200, it is going to execute thread C, and finally it is going to after finishing it is going to print that exit from thread C, right? So this is the first run. Now when I run this program for the second time, let's see what do we observe, right? Now in this particular second run, what has happened is, see, start thread A, start thread B, start thread C. Okay, so at this moment and then the main thread, it kills itself, it is over, so it exits from the main thread. So at this point there are 3 independent runnable threads which are available. Now in this second run, what has happened is, on my CPU, okay, it has tried to execute thread A. Okay, it has tried to execute thread A. That means thread A has tried to take the control of CPU. But as you can see, when thread A gets the control of CPU, the very first thing is, if I is equal to 1, okay, it says yield. Okay, as a result, what has happened is, okay, although thread A has been able to get the access of CPU, but for very first iteration there is a yield method that is encountered. As a result, the control it has relinquished its control on CPU, and it has passed it on to the next available thread, right? So then you can see here, okay, that that means, you know, directly the control passes to thread B here. Now thread B, for iteration 1, j equal to 1, it is executed, right? Then thread C, okay, you know, for k equal to 1, okay, for k equal to 1, thread C is printed. But then after printing this line, as you can see here, okay, for thread C, once it takes against the control of CPU for k equal to 1, it has just printed this message that from thread C k equal to 1. But soon after that there is a if statement which puts the thread for slip, right? So as you can see here, okay, as you can see here, so it is printed from thread C k equal to 1. But soon after this there is a sleep method that is called. As a result, thread C is put to sleep for certain time limit, right? And then the control passes back to thread B. Now thread B for j equal to 1 already printed. Now the second iteration of thread B starts, and then the third iteration of thread B starts. And when j is equal to 3, okay, in the code, when j is equal to 3, what has happened? A stop method is called, which forcibly kills the thread B. Okay, so as a result, if you see the output here, okay, so the moment, see, for j equal to 2 it has executed, for j equal to 3 it has executed, and just after this there is a if statement that is encountered, and there is a stop method that is called. As a result, this thread B will be killed here itself. So you can see nowhere else thread B again comes into picture. Even that exit statement, exit from a particular thread, that also is not getting printed. Okay, now after, you know, B is killed, and what has happened is, here we have just put thread C for sleep. Okay, so then who gets, out of 3, who gets the control of processor? It is thread A. Okay, now here as you can see, okay, here somewhere here the thread A was about to get the control of CPU, but now you know, because of the yield method, it lost the control. So now when thread A again gets the control of CPU, okay, you know, it is which line that is executed? You see here, first time when thread A was executed on CPU, I equal to 1, and for I equal to 1, yield was already called. Okay, so after yield it lost the control. So when it again gets the CPU, it comes to the next line here in the same iteration. As a result, you can see from thread A, I equal to the value of I, that is 1, being printed. Okay, so you can see here from thread A, I equal to 1 being printed. Okay, but after that thread A, okay, it exits, fine, and then it you know, the control of thread C is again resumed. Okay, those milliseconds are elapsed and control of thread C is resumed. And now we had already seen thread C executed for one iteration. So now it starts executing from the second, third, fourth, fifth, sixth iteration. It goes on executing, and this way it will finish its execution here for k equal to 200, and it will exit from thread C. Okay, so this is the second run. In the third run also a similar things happen, right? Now here you can see thread A and thread B, they are not getting the access of CPU, but let's say thread C is first getting the access of CPU, so it executes iteration k equal to 1. But soon after this there is a sleep method that is encountered, so thread C is put to sleep. Okay, then after thread C, maybe thread A tried to get the control of CPU, but there was a yield method. Okay, so it relinquished its control. C is already put on to the sleep. A has relinquished the control, so who is left is B. So then thread B is executed for j equal to 1, j equal to 2, j equal to 3, and when j is equal to 3, after printing this message, there is a stop method that is encountered. So thread B is abruptly stopped. So now C is already in the sleep mode. So what is remaining is A. So after the yield, it comes back to the next line after the yield method, and it prints A equal to the thread A, that is I equal to 1. And then thread A exits, and then after those many milliseconds, okay, thread C has gained the control back and thread C is executed. As you can see here, thread C is executed. Next we are going to see what are these thread exceptions. As I have told you that when we use this slip method, you saw that exception handling took place. Okay, so let us see what are thread exceptions. A call to slip method is enclosed in a try block and followed by a catch block. We have just seen that in the code. This is necessary because the slip method throws an exception which should be caught. Now what exception? So now if we fail to catch an exception, the program will not compile. Java runtime system will throw illegal thread state exception whenever we attempt to invoke a method that a thread cannot handle in a given state. See, now the problem with this slip method is what? Suppose a particular thread, suppose a particular thread is already in a block state. Suppose a particular thread is already in a block state, and you might try to call slip method. In that case, your slip method will not execute. There will be a problem. Okay, slip method can be called only if a particular method, if a particular thread is running. So if it is already in a block state, how can you? So as a result, whenever you are using the slip method, careful exception handling mechanism is required. Okay, so another example, a slipping thread, it cannot deal with resume method because a slipping thread cannot receive any instructions. The same is true with suspend method also when it is used on block that is not runnable thread. Okay, whatever I said for slip method, it is also true for suspend. Now, if a thread is already in a non-runnable state or in a block state, and then you try to call suspend method, it might give you problem, right? As a result, whenever you are going to use this suspend method, like how I have done it for slip method, for suspend method also you will have to put it under try block, and exception handling mechanism should be required. Okay. Now, whenever we call a thread method that is likely to throw an exception, we have to supply an appropriate exception handler to catch it. Now, you must be wondering how many different types of exception handling mechanisms are there for these kind of thread exceptions. So the catch statement, it may take one of the following forms. Okay, so there is a catch block where we can write thread death e. Okay, so thread death class, okay, this is invoked in the catch statement when you are catching an expression wherein a particular thread is already killed. Fine. Or interrupted exception. This class, the object of this class is used in catch block when one cannot handle that particular thread in the current state. Okay, then illegal argument exception. This is invoked when illegal method argument is encountered. And for any other, or in general, when you catch any kind of exception, you can simply say exception E. So that will handle any kind of exception. Okay, so we will restrict our discussion on exception handling over here, because that is a separate topic that we are going to deal with later. A detailed version of exception handling, how it is taken care of, will be taught to you in the next chapter. So right now we will halt with the discussion of exception handling with threads. Okay, now let us talk about thread priority. Now, so far the programs that we saw, you must have realized that there are, say, 1, 2, 3 threads which are runnable. How CPU how they get the control of CPU, how they get access to CPU. As you run the program multiple different number of times, you get different outputs. So it is just based on the availability of CPU that they randomly get the control of the CPU, right? And also the CPU smartly switches between these particular threads in a very fast manner, so it appears that they are running parallelly, right? All this is happening because so far each thread that we had created, it had the same priority or equal priority. Okay, so when the threads have equal priority, okay, then just based on the time slicing, it takes the decision. Okay, but now we will see here how threads can be also given priority. Without priority, we know the threads are executed in a round robin fashion. So we have a waiting queue of different threads which are runnable. Okay, so when a particular thread is serviced by the CPU, it goes to the end of that particular queue. So that next its turn will come after all the other runnable threads are given the CPU. So this is a round robin fashion when the threads are given equal priority. So now let us set some priority for thread. In Java, each thread can be assigned a priority, and which affects the order in which the scheduling in which it can be scheduled for running. The threads that we have discussed so far, they have the same priority. The threads of the same priority are given equal treatment by Java scheduler, and therefore they share the processor on first come first serve basis or in round robin fashion. Now Java now permits us to set priority of a thread using a method called as set priority that can be invoked as follows. You have to simply write the thread name, which is a thread object's name, dot set priority, and in bracket there is a int number. Okay, now what is int number? Int number is an integer value to which the thread's priority is set. The thread class of java.length package, okay, it defines some priority constant. So thread class has some well defined priority constants. Okay, which are the constants? You have a constant called as min underscore priority. So this constant represents 1. So the value 1, integer value 1 is basically minimum priority. Then there is another constant called as norm priority, norm underscore priority. Okay, so 5 happens to be the normal priority, and max priority, number 10, happens to be maximum priority. So 1 means minimum priority, 10 means maximum priority, and 5 is a normal priority. So you can directly make use of these constants. Notice that here it should be norm underscore priority. As an example, let us see. For example, I have an object of class A, say thread A, then thread B and thread C. I can simply say thread A dot set priority 5. Okay, so thread A will get a normal priority. If I say thread B dot set priority 10, it will get, thread B will get the maximum priority, and if I say thread C dot set priority 1, thread C will get the minimum priority. Now how this setting of priority, how it affects the execution of threads. Suppose at a particular instance the CPU is available, okay, for 3 different threads. Okay, 3 different threads can take the control of CPU. In this case, who will take the control of CPU? It is decided upon the priority. So the thread with maximum priority will be given the CPU first, then with the next level of priority, and so on. Okay, so this is not now the problem is no longer first come first serve basis, it is based on priority. The int number may assume one of these constants or any value between 1 to 10. Note that the default setting is normal priority. So far we had not set any priorities for your threads. So default priority is a normal priority, norm underscore priority. It's a constant that is defined by the thread class of java.lang package. Most user level processes, they should use this normal priority, and you can say plus or minus 1. Background tasks such as network IO or screen reprinting, all this kind of background activities on your computer, they should use a value very near to the lower limit. Okay, we should be very cautious when trying to use very high priority values. This may defeat the very purpose of using multiple threads. By assigning priorities to threads, we can ensure that they are given the attention or lack of it. Showing you a PPT, let us see the actual working code. So here I have created a package called as thread priority demo. Now I have written a class A. What this class A does, it is basically extending thread. So it's a thread class. In the run method, it first, once it starts running, once the thread starts running, it first prints that thread A had started. Then for iteration I equal to 0 to 4, okay, for 4 iterations, it is going to print for every iteration that thread A is equal to the value of I. So for every iteration it is going to print this, and once it is over, it is going to simply print a message that we exit from thread A. Now what we'll do is we'll try to change this value. I will make it 100. Okay, then I have class B. In class B, okay, which also extends thread, in the run method, what I have done is, again, once the run method starts, that means once the thread B starts running, it will first print a message thread B started, and then again see here for j equal to 0 to say 50, for 50 iterations it is going to print, every iteration it is going to print the value of j, thread B and j's value. So j will vary from 0 to 50, and once it has executed everything, it is going to print exit from thread B. Then we have thread C. Okay, in the run method, in the similar basis, once thread C starts running, then it will print thread C started. Okay, and then for k equal to 0, k less than 4, k plus plus, let me make this as again 100 or say 200. So for iteration from 0 to 200, it simply prints for every iteration the thread C's value, and then it prints at the end exit from thread C. Okay, so these are 3 thread classes that I have created. Now in the main, okay, so in the main we have the main method over here, main thread over here. Now main thread is running currently. While main thread is running, it creates thread A object, B thread B object, thread C object. So at the end of this, we have 3 threads being created, but they are in newborn state. They are not yet runnable. Thereafter, I am setting the priority. So what I am saying, thread C dot set priority. I am trying to set the priority for thread C. Okay. Now, as I have already told you that thread class from java.lang package, thread class, it has an inbuilt field that is called as max priority, which is a constant field. So this max priority constant field, it stores value 10. Notice that this max priority field, it's a static field. Why it's a static field? Because to call this particular field, we are using class name and dot operator. So only the static variables or class variables can be called using class name and dot. So in the thread class, inbuilt class called as thread class in java.lang, this max priority, also mean priority and normal priority, these fields which are constant fields, they are static fields. Okay. So what I am doing here is thread C dot set priority. I am setting the priority of thread C to max priority. So I am just saying thread dot max priority. So thread C's priority value is 10. Now thread A, I am setting the priority to min priority. So thread A's priority value is 1. So thread C has maximum priority, the value is 10. The thread A has minimum priority, the value is 1. The thread C has maximum priority, the value is 10. and I want to say thread B's priority value is 1 unit more than whatever is the priority value of thread A. So I can say thread B dot set priority. I am saying thread A dot get priority. Now this get priority function of the object called as thread A, what it will do is it will find out what is the priority that is set for this particular object thread A, and to that value it is going to add +1, right? So A dot get priority, thread A dot get priority will give you what value? 1, because you have set the priority of thread A as 1. So this is 1 here, and to that one another 1 will be added. So the priority of thread, okay, priority of thread B, okay, its priority will be equal to 2, that is 1 plus 1. So at this level, thread C has the highest priority, thread A has the lowest priority, and thread B you can say it has a medium priority or in between intermediate priority, you can say. Now thereafter, thread A, ABC, which are currently in newborn state, we are making them run. So it will print a message on the computer screen, start thread A. Okay, by calling the start method, thread A has been made runnable. Then again it will print on the computer screen, start thread B. By calling start method, thread B also has become runnable now, and it will print thread C, start thread C, and by calling start method of thread C also has become runnable. So main method thread, which is there, main thread, it has invoked, okay, 3 other threads, thread A, thread B, thread C, and which are now runnable. So after this, the main thread, it exits by saying exit from the main thread. So at this moment here, okay, you will see that there are 3 independent threads which are available. Now how the setting of priority affects, the control of CPU being given to the threads. Now suppose, although there are 3 threads which are runnable, okay, say 2 threads are competing for getting the access of CPU, say thread B and thread C. Now at this moment it finds out of B and C who has the highest priority. C has the maximum priority. So since 2 of them they are competing, B and C has higher priority, so C will be given access. Now C will be executed not wholly, because it has highest priority. It does not mean that thread C will be completely executed. No. So it will the processor will execute some part of C, and then it will do the switching. This is called as time slicing. After certain time it will be doing the switching. Now who is the next contender? A and B, they are waiting now. C was getting executed. So then either A or B, one of them will get the access based on whether they are available or not at that moment. Now then while giving the control, it again decides, okay, A and B are contenders. Who has the higher priority? B has higher priority, so B will be given the control. Okay, so once B gets the control, B will start executing, C and A will be waiting, and so on. Okay, now it can so happen that next your C might not be available, it is A who is available, so A will be given the A will be given the CPU, although C has higher priority. Okay, although C has higher priority, C might be doing some other thing. C might not be waiting for processor at that moment. Okay, say A is waiting, so A will be given priority, and so on. Okay, so this behavior, it will change based on every run. So let us execute this code and see. I will just say, for better readability, thread A started running, thread B started running, thread C started running. Okay, save, and I will run this code. Okay, let's see what output do we get. Notice that C has highest priority, B has the next priority, and A has the lowest priority. So now start thread A. Okay, after printing this particular line, thread A has become runnable. After printing this particular line, thread B has become runnable. After printing this line, thread C has become runnable. At the end of this, after making all 3 threads runnable, main thread's job is over. So main thread kills itself, it stops. So by printing message exit from main thread. So at this moment there are 3 threads who are now in a runnable state. 3 threads who are waiting for CPU, right? Now out of these 3 threads, C has the highest priority compared to B and A. So as you can see here, thread C started. Thread C started and thread C it started running. Right? Thread C gets the access of CPU, it started running. Right? So then CPU executes thread C for iteration 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just goes on. Now it may so happen, okay, that if there is nothing else which is more important than C, okay, it may so happen that processor might completely execute thread C and then go to other processes. But suppose there is another thread which is competing for the CPU, which is almost near the priority of thread C or something like that, then it may do the switching. Halfway it can stop execution of thread C. So you can see here, thread C has been completely executed by the processor, okay, and then thread C exits. Now after executing this thread C, who are the contenders next? It is B and A who are the contenders for CPU. Out of B and A, who has the highest priority? B. So as a result, you can see message here, thread B started running. Okay, run method of class B has started. So here CPU gets the control, thread B gets the control of CPU. It executes for iteration 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can just go on and see. And it completely executes the thread till 50 iterations and then it exits from thread B. And now thread C, highest priority thread is executed. Next the lower priority B has been executed. And now the lowest priority thread which is still waiting, that is A, it will start execution and thread A is completely executed and we exit from thread A. Next we shall see how to access threads ID and priority. Now each thread has a unique ID. Okay. Now each thread also has a unique priority. If you don't set the priority, as we have already seen, the default priority that is assigned to the thread is normal priority. The value is 1. The normal priority, the value is 5 by default. Okay. Now many a times in a program you might require threads ID, whichever thread that is currently being running, you want its ID and priority to be printed. Okay. So now each thread in multi-threaded program, as we know, it has a unique numeric identifier associated with it, that is called as thread ID. Java allows us to access threads identifier or ID using the following method. Okay, so you have to write the thread name, that is thread B, object of class B, which extends thread. So you can say thread B dot get ID. So get ID method is going to give fetch whatever is the ID for thread B. Okay, or there is another way, you can say thread dot current thread dot get ID. Now note students that in the class inbuilt class called as thread, which is there in java.lang, they have a static, like how we have static fields, they have designed a static method called as current thread. So this static method also you can call this static method static method called as current thread. What it will do is it will point to the thread which is currently active. Okay, so why it is a static method? Because to call this method I don't use object name like over here, I don't use the thread object name, I am using class name and dot operator. So this thread dot current thread method, it will return what? It will return which thread is currently running. And then dot get ID method, like what we have done here, this dot ID method will then further give you the ID of that thread which is currently running. So either you can adopt this one or you can go for this one. Okay, so that you can get the ID of particular thread. Now this is a program. Okay, class A, I have simply modified this. So class A, in the run method I am first printing this is thread A and I am printing the thread ID by saying thread dot current thread dot get id, and then for that same thread A I am printing thread priority by saying thread dot current thread dot get priority. Only this much. Similarly for second class, once thread B starts running, I am just printing this is thread, I am printing its thread id, that is thread dot current thread dot get id, and thread priority that is thread dot current thread dot get priority. Only this much. And same for thread C. So basically run methods of all these thread classes that I have created, it simply prints whichever thread is there, its thread id and its thread priority. It prints that. Now in the public static void main thread, what it does, it creates 3 threads here which are now in the newborn state. Then it sets the priority for each of these threads. So it sets thread A with minimum priority, thread B with normal priority, thread C with the maximum priority. So C is maximum, A is minimum, B is normal priority. Then it prints on the computer screen, this is main thread. Now you also have to print the priority of main thread. So you are saying thread id. Okay, how do you get control of the main thread? Because it is main thread who is currently running. It is main thread who has created these, and it is the main thread who is going to invoke or who is going to make this ABC runnable. It is this main thread. So to get the ID of main thread itself, we will say thread dot current thread dot get ID, and to get the priority, we will say thread dot current thread dot get priority. Okay, I had to use this method because I could not use object name and dot operator because we have not specified any object name for the main thread, right? And then after printing the main threads, ID and the priority value, it prints let's call other threads in sequence ABC, and then we are making thread ABC runnable. Now in what order they will be executed, that is based on CPU and based on the priority, as we have already discussed. We are only going to see how the thread ID and how the thread priority will be printed. Okay, so once this program is run, the interpreter starts running from here. Okay, after setting the priorities, it comes here and it prints this is main thread, and then it will print the thread's ID and priority. So you can see here, this is main thread, thread ID 1, thread priority 5, right? After printing this, then it will print let's call other threads in sequence ABC. So you see next line here, let's call other threads in sequence ABC. Now thread A, B, C are invoked. So all three ABC, they are contending to get CPU. Now in this particular run, what has happened is, since thread C has the highest priority, thread C, it gets the access of CPU. So thread C from runnable, it becomes running. So the run method of thread C gets executed. So it prints this is thread C, as you can see here, this is thread C, and then thread ID, that is thread.current thread.get ID, will print the ID of the thread, that is 10, because you had set the C to the maximum priority. So you see 10 here. Okay, and run method is exhausted. That means thread C is completely run. So it comes back. Okay, and now when it comes back, okay, there are two other methods which are contending. Okay, that is A and B. But let's say at that moment B is not contending for CPU, only A is contending for CPU. Okay, so then it executes A and says this is thread A. Okay, this is thread A. So A is gets the access of CPU. It prints this is thread A, and then it prints its ID, thread ID and thread priority. So you see thread ID is 9 and thread priority is 1. And then finally only one thread is remaining from your program, that is B. So this is thread B and priority is 5. So this is how priority and thread ID of different threads can be executed. Now one thing you can note, students, see the thread ID of this thread is 1. Thread ID of this is 11, 9 and 10. Okay, so there are in between thread IDs that you need to note. Before we exit, we will see a last concept, and that is called as synchronization, a very important concept of operating systems. So far we have seen threads that use their own data and methods provided in the run methods, right? So whenever we say the thread is running, only the data from the run method is executed. But many a time what can happen is these threads, they may utilize, apart from whatever code that is written in its run method, they may utilize some other resources. Okay, so what happens when they try to use data and methods outside themselves? On such occasions, they may compete for the same resource and may lead to serious problems. Okay, now you see whatever is written, whatever code is written within the run method of that particular thread, it is local, or it is personal to that particular thread. So even though three threads they are contending for only CPU, but they are not contending for any other method or any other class. They are not contending for any other resource, right, apart from CPU. But it can so happen that maybe there is some data, or there are some methods outside this run method of theirs that different threads might want to use at the same time. Okay, so in such cases, when many threads want to use the same resource, there will be competition, and that may lead to different problems. Example, say one thread may try to read a record from a file while another is still writing to the same file. This is a common problem. Okay, let's say you have this is happening in real life also. Let's say you have a file that is stored on the server, and let's say multiple students have opened the file. One student is trying to delete one sentence, whereas the second student at the same time is trying to add another sentence in the same file. Will it not be a problem? Okay, your file management system, it takes care of all this. Okay, there is something called as mutual exclusion. There is something called as locks. There is something, suppose there is some problem happening, then there is something called as rollback recovery. All this is already there in such systems. Even in DBMS, database management systems, or in the file management systems, these things are there. But if these things are not there, if say multiple users are trying to read or write the content on the same file, it could be a serious trouble. There will be inconsistency of data, right? So depending on the situation, we may get strained results. Java enables us to overcome this problem using a technique known as synchronization. Now, keyword called as synchronized, it helps us to solve such problems by keeping watch on such locations. For example, the method that will read information from a file and the method that will update the same file may be declared as synchronized. Okay, now synchronize is a keyword. For example, suppose update is a function that all the threads might try to use, then you just declare that method with a keyword called as synchronized. So this code over here will be synchronized. Okay, when we declare a method called as synchronized, what Java does is Java creates a monitor and hands it over to the thread that calls that particular method for the first time. Now this monitor is something like a key, right? So as long as the thread holds that monitor or key, no other thread can enter the synchronized section of code. Monitor is just like a key, and the thread that holds the key, only that can open the lock, right? So whichever thread gets hold of this monitor, and whichever thread has, after getting hold, has entered that synchronized code, only that will be able to edit the code, and all other threads who want to access the same code, they will be locked from accessing it. Only when this thread finishes its execution and comes out, only then one of the next threads will be given this monitor or the key. Again, the second thread, once it starts execution in this synchronized code, all other threads will be locked from or prevented from accessing that code and modifying that code. So this way inconsistency will be solved, and this is basically synchronization. It is also possible to mark a block of code as synchronized as shown below. Okay, for example, I know that this particular block of code, it's not a function, I just want to say that, say this is a block of code, compound statement, and this code is synchronized. That means if one thread is accessing this code or modifying this code, all other threads should be prevented from editing or modifying this particular code. In that case, this compound block itself can be called as synchronized. You can just write synchronize in bracket lock object. So this code will be synchronized. Whenever a thread has completed its work using synchronize method or block of code, it will hand over the monitor to the next thread that is ready to use the same resource. Now I will show you one example. I have created a class called as pyramid, which has a method called as draw pyramid. Now this draw pyramid, what it does, I'll tell you. It simply, it's basically printing a pattern of pyramid. Okay, it simply prints a pattern of pyramid. Now pyramid of stars and pyramid of hashes. There are two kind of pyramids that can be printed. Pyramid made out of stars, star character, and pyramids made out of hash character. Okay, so this is a general draw pyramid method that allows you consider whichever character ch, may it be star, may it be dot, may it be comma, may it be plus, whichever character you specify. Using that character, it is going to print a pyramid. Okay, so this is a pyramid class. Next, I create a thread class A that extends thread. Now within this thread class A, I am creating an object P of pyramid. Now this is a constructor of this particular thread class A. In this constructor, I am passing this pyramid object P, and I am just saying this dot P is equal to P. Okay. Now in the run method of this class A, using that object P of pyramid, I am calling draw pyramid method, and this particular thread called as A, it tries to print the pyramid with stars. So when this function is called, when this particular method is called, okay, the call will be linked to the code, ch will be supplied with star, and all this printing of pyramid will happen with stars. So basically this thread called as thread A tries to access this draw pyramid method and try to print the pyramid with stars. Now I have another class B extends thread. Now this class also, the code is similar. It has an object P of pyramid. The constructor over here, it sets P to this P, and then in the run method, this particular thread, it tries to call draw pyramid method, and it tries to construct a pyramid of hashes. Okay, so when the call gets linked to the code, hash will be copied in ch, and all this pyramid will be printed of hashes. So as you can see here, there is a class called as pyramid. It is not a thread, it is simply a class. Now there are two threads, thread A, thread B. Both the threads are trying to access the resource called as class. One thread is trying to access the resource, its draw pyramid method it wants to use, and it wants to print a pyramid of stars. Whereas the second thread, again it tries to access the same pyramid class and same draw pyramid method, and tries to print the pyramid of hashes. Now let's see the main method. Okay, main class, public static void main. Here I am creating object POBJ of pyramid class. I am creating thread A, thread B. Notice that while creating thread A, the constructor of A, we are passing POBJ, the pyramid object. Okay, so here this is that object that is created is passed. So this P is actually the P object that is you have created here. Okay, then when the second thread B is created, the constructor here you are passing POBJ, the same object. So here also the constructor call gets linked to the code, and what is this pyramid P? P is basically a formal parameter for the actual parameter OBJ, POBJ. Fine. And then after this, we are starting thread A and thread B. So after saying thread A dot start and thread B dot start, what will happen is thread A and B both are now runnable. Okay, both can now compete to get the access of CPU. Again, see, we have not set any priority for these threads, so they are of equal priority. So now both of them, let's say, what happens when they try to compete for getting access to that draw pyramid method of class pyramid. when I run this program, okay, what I get is this. First it tries to print star, okay, then hash, then it tries to print some hashes, then some stars. Notice that star is basically the thread 1. So basically thread 1 got the access of CPU. It tried to print one star. By that time thread 2 was switched. Thread 2 printed hash. Then again thread 2 got the control. It printed those many hashes, but the triangle was not yet complete, and the switching happened. And who got the control back? Thread A got the control back, and thread A, who had already printed one star, it now printed 2 stars, 3 stars, 4 stars, and so on. It printed entire pyramid. It is over now, and then 2 stars or 3 stars were remaining to be printed here. So again thread B resumed its job. It wanted to print 3 more, total 6 stars. 3 were already printed before switching, so remaining 3 it prints here, and then it completes its pyramid. But you see, when this particular method called as draw pyramid, when this is non-synchronized, it is not synchronized, both of them, they contend to access this method, and as a result actually you wanted 2 different pyramids, one pyramid of stars, second pyramid of hashes. But since both of them are contending for the same resource called as draw pyramid, okay, switching takes place and none is able to finish the triangle, and everything is a mixed jargon what you get. Now I will edit this code and I will simply use one small keyword. Okay, so this is my original code. I will only now use a word called as synchronized to this draw pyramid, because I know that this draw pyramid method is being accessed simultaneously by thread A as well as thread B. So I will use a keyword called as synchronized. So now when synchronized keyword is used, what will happen? JVM will give a monitor to whichever thread that first gets access to this particular draw pyramid. So unless and until the first thread does not completely execute this particular code, it will not leave this synchronized section. And once first thread has finished printing the star, then it will exit the synchronized section, and then the second will be given the permission to enter the synchronized section. So when you run this code, you see properly 2 triangles getting printed. So this triangle is printed by the thread 1 and this is printed by thread 2. Okay, once thread 1 gets the control of the synchronized section, it will not leave the synchronized section till it prints the whole triangle. The second thread is it is blocked from entering the synchronized section unless thread 1, who has already gained the control, finishes its work. And once thread 1 finishes its work, then thread 2 gets the control of the synchronized section, and that's how you get 2 stars that is printed on the computer screen. Okay, the last concept here is called as a deadlock. Say 2 or more threads are waiting to gain control of a resource. Due to some reasons, the condition on which the waiting threads rely on to gain control, it does not happen, and this is called as deadlock. Just an example, let's say thread A is currently executing method 2. Okay, now to finish this method 2, it requires method 1 to be executed completely, right? But at the same time, parallelly thread B is running, who has who is executing method 1, but for method 1 to finish, it is waiting for method 2. Okay, now if the synchronized keywords are not there, just exclude the synchronized keywords. What will happen is, thread A will not be able to execute this method 2. Why? Because it is waiting for thread B to finish its synchronization method 1. So thread A will not be able to finish its execution of method 2. So method 2 will be occupied by thread A. Similarly, thread B, it will not be able to execute this method 1. Why? Because method 1 is already occupied by thread A. Okay, now for thread B to complete this particular method, it wants method 2 to be released by thread A, but thread A has not finished processing of method 2. As a result, there is a deadlock. So that means one thread is waiting for a resource that is occupied by second thread to finish its work, and second thread is waiting for a resource from the first thread to finish that work. So both are waiting for each other, and as a result there is deadlock. Okay, so in general we assume that thread A must access method 1 before it can release method 2, but the thread B, it cannot release method 1 until it gets hold of method 2, because these are mutually exclusive condition, a deadlock occurs. So that is it for today's lecture. Thank you.